So again, we recognize this as the sum of an arithmetic sequence. Arithmetic because it's like y equals mx plus b, n is to the first power. So we can use our sum of an arithmetic sequence as the average of the first term and the last term times the number of terms we have. This a sub 1 just in general stands for the first term. In this case, we're going to get our first term by plugging in where they're telling us to start. And they're actually telling us to start with the fourth term. So don't get too hung up over a sub 1. That a sub 1 in this case is actually going to be a sub 4. You always get that first term by plugging in whatever that is down there. So if I plug in a 4, I get 2 times 4 minus 7 is just 1. And then I'm going to get the last term by plugging in the last number they want me to plug in. So a sub 53 is 2 times 53 minus 7. And my calculator tells me that that is 99. Well, that's nice. So if we take the average of that first term and that last term, we see that the average of those terms is 50. And then how many of those do we have? Well, it's tempting to do 53 minus 4 and say 49 and be done, but there's always one more than you think. There's that tricky little plus 1. So the n is always going to be the top minus the bottom plus 1. If you were to count on your fingers 4th, 5th, 6th, all the way up to 53rd, you would have 50 terms there. So remember when we started off with a 1 at the bottom, it was super easy, and you were just like, bam, from the first term to the 53rd term, that's 53 terms. But if you tried to subtract 53 minus 1, you would have gotten 52 terms. So you can't just subtract, you have to add that extra 1. So back to where we were, so where there are 50 terms. So if you have a 50 times, that sum is going to be 2,500. And again, if that was too fast, number 17 on this worksheet I walk through a lot slower. There you go.